Okay, so today we will discuss Newton's method for multiple root. And yesterday I have defined that in case of multiple root, if R is a root, you can write fx equals to x minus r power m phi of x. Okay, so in multiple root we can write fx in this form. So, so we can treat Newton's method as fixed point. So what is the formula of Newton's? Xn plus 1 equals to g of xn. And what is gx? This is x minus f by f dash. So you can apply the previous formula xn plus 1 equals to xn minus fxn by f dash xn to multiple root. But we will see that this formula is applicable, but convergence will be affected. So firstly, I will simplify this g. So, so what is gx is? So now g of x is x minus fx. So what is fx? X minus r power m phi of x. And what is its derivative? Its derivative is apply product rule. So first derivative of x minus r x minus r minus, sorry, m power rule phi as it is, then x minus r power m as it is, derivative of phi, which is phi dash. Okay, so this is the derivative, and you can simplify this g further. Take factor x minus r m minus 1, this will cancel out, this will cancel out, you will get 1 x minus r and 1 minus. So after cancelling the factor, you have x minus r phi of x, then m phi of x plus x minus r phi dash x. So this is my g. Okay, and we all already know the convergence result of fixed point. हमने न्यूटन को क्या लिखा है? वी राइट न्यूटन एज फिक्स पॉइंट. तो कन्वर्जेंस कब होती है? जब डेरिवेटिव रूट पे 1 पे छोटा हो. यही है. तो हम इसको डिफरेंशिएट कर लेते हैं. फाइंड जी डैश एक्स, देन फिट एक्स इक्वल टू आर. तो मैं एक साथ ही कर रहा हूँ. तो 1 का x का डेरिवेटिव 1 हो गया. सो नाउ डिफरेंशिएट दिस टर्म. तो इसको मैं 3 फंक्शन ले रहा हूँ. एक x माइनस आर, टेक दिस फर्स्ट फंक्शन, phi x take this second function, and 1 by something this, take this third function. Then apply product rule and then fit x equal to r. तो जो फर्स्ट का डेरिवेटिव आप करोगे x माइनस आर, डेरिवेटिव वुड बी 1 x की पावर. तो बचेगा क्या? फाई एक्स, x की जगह r, m of phi r, and here you fit x equal to r, this will be 0. और बाकी टर्म में सेकंड, अब x माइनस आर एज इट इज रखोगे, फाई का डेरिवेटिव करोगे x माइनस आर एज इट इज, देन यू फिट x इक्वल टू r, दिस विल बी 0. सो सेकंड टर्म विल बी 0. थर्ड का डेरिवेटिव करोगे, इसका डेरिवेटिव जो भी आएगा साथ में x माइनस आर होगा, देन यू फिट x इक्वल टू r, दिस विल बी 0 अगेन. So you only get first term, and phi r will cancel out, so 1 minus 1 by m. And what is m? M is multiplicity which is greater than or equals, sorry, which is greater than or equals to 2. So m is a number which is 2, 3, 4. So first derivative of g is non-zero. So this means convergence is first order linear. वैसे हमने न्यूटन क्या पढ़ा था? अगर आप न्यूटन सिंपल रूट पे लगाओगे, इफ यू अप्लाई न्यूटन ऑन सिंपल रूट, then g dash r is 0, and you can check from this formula if m equals to 1. If m equals to 1, you got this equals to 0. But in multiple root, m is starting from 2, so this will be non-zero. So first derivative of g is non-zero means that you can apply this formula of Newton, but you are getting only first order convergence. तो नेक्स्ट इसका मॉडिफिकेशन है. सो यू कैन मॉडिफिकेशन टू गेट सेकंड ऑर्डर कन्वर्जेंस. तो दो मॉडिफिकेशन हम पढ़ेंगे इसमें. फर्स्ट मॉडिफिकेशन है कि so if g dash r is 0, then you can get quadratic convergence. अब how you can make this 0? अब डायरेक्टली 0 तो नहीं कर सकते, बट इफ देयर इज, अगर यहाँ पे m होता तो m 1 - 1 ये 0 बन जाता. यहाँ पे m होता मतलब यहाँ पे m होता, यहाँ पे m होता, यहाँ पे m होता, मतलब यहाँ पे m होता. So if you had m here, then you will get first order derivative equals to 0. तो फर्स्ट मॉडिफिकेशन न्यूटन का यही है. So what formula you take? You take xn plus 1 equals to g of xn, and take g of xn, this m, and this formula is called modified Newton. Okay, just multiply with this number m, and when xn plus 1 closer to xn, fxn will be 0. Okay, and there is a limit. You can apply this formula if you know m, and m is multiplicity of the root, and that is unknown. So in most of cases m is unknown. So second modification of this method, which don't use m. So this says that firstly you define, एक नया फंक्शन डिफाइन करते हैं, hx क्या है? f by f dash. ओके, यू कैन राइट, एंड यानी कि hx ये है, दिस वन f by f dash हमने सिंप्लीफाई कर रखा है इसको यहाँ. So what is hx? f by f dash. इसमें वैल्यू फिट कर दो चाहे आप दोबारा से, बट हमने कर रखा है पहले. x minus r phi of x, then derivative plus x minus r power m phi dash x, and you can cancel x minus r m minus 1, so you got x minus r phi x. Okay, अब if fx equals to 0, so this means hx equals to 0. So either you find root of h or you find root of f, both are similar. But if you look more closely to hx, so hx is x minus r phi x divided by m of phi x plus x minus r phi dash x. So if you fit this equals to 0, then you got x equal to r only one time. And you can check this term, this term is non-zero at r. So what is this term? M phi r by m phi r plus r minus r phi dash r. So this becomes 0. So phi r. So this is 1 by m. So this means if you see in root finding case, then either you find root of f or you find root of h, both are same. But at fx क्या था? Fx equals to x minus r power m. So r is a multiple root of fx, but in hx you have only one factor. So x equal to r is a simple root of hx. And you can apply Newton's method on simple root, you will get quadratic convergence. So rather than applying Newton's method on f, we apply Newton's on hx to get quadratic convergence. Okay, so to get, or you can say x equal to r is a simple root of hx, and Newton's method provide second order convergence for simple roots. Therefore, you need to apply Newton's method on hx. So what will be formula? Formula वही है same आपका hx by h dash x. So if you are writing in discrete sense, so this is hxn divided by h dash xn. And you can simplify it bit further. So what is hxn? This is fxn by f dash xn. And what will be the derivative of h? So this will be apply u upon v formula. So f dash xn square, यहाँ पे आ जाएगा आपके पास f dash x minus fx f double dash. So write xn here. Okay, derivative of f by f dash. This is the derivative. So if you bit simplify it, so this is fxn f dash xn, then division f dash xn square minus fxn f double dash xn. So this is the formula, and you can remember it with, in short, you can remember this g is x minus f dash, this one, and division f dash square minus f double dash. So this is the another Newton's method for multiple root, and there is no m. You have to memorize this formula. So what is iteration scheme? Xn plus 1 equal to xn minus f dash divided by f dash square minus f double dash. And you can use both formula. You can also use this one. You can use this one. If you know m, this formula involve less computations. Just f by f dash here. But this formula involve more calculation, but there is no m. So if you don't know multiplicity, but you know that there is a multiple root, then you can apply the second formula. And both formula provide second order convergence. So in conclusion, for multiple root, यू कैन आल्सो अप्लाई सिंपल फार्मूला, जो सिंपल न्यूटन है वो भी अप्लाई कर सकते हो। सिंपल मतलब दिस वन, सिंपल में ये भी लगा सकते हो, देन यू विल गेट वन ऑर्डर कन्वर्जेंस, फर्स्ट ऑर्डर। आल्सो यू कैन अप्लाई this one, or you can apply this one to get quadratic convergence. Okay, any doubt? And these two formula are known as modified Newton's method. Okay, so they are known as modified Newton's method for multiple roots. Okay, right here, so these are modified Newton's method for multiple roots. So let us apply these two formula on two examples. Let's take first example. So I am saying again and again, if you know m, then it's better to apply this formula to reduce your calculation. And if you don't know m, then you don't have any choice. You have to apply this formula. So in first problem, I am giving you m. So it says that let you have an equation fx e power x minus 1. Then show that f has a root of multiplicity 2 at x equals to 0. Apply Newton's method to locate the root. Okay, so firstly it says that you need to check. So root क्या दे रखा है उसने 0, and multiplicity you need to verify. Okay, so you need to check what is the multiplicity. So how you check multiplicity? So this is my fx, differentiate it, write its first derivative, and then fit root, which is 0. So e power 0, 1 minus 1, this is 0. First derivative is 0, so you need to compute second derivative, which is e power x. And at root, second derivative is 1. ये रिजल्ट था ना, अगर सेकंड डेरिवेटिव नॉन जीरो है इसका मीनिंग क्या है? मल्टीप्लिसिटी 2. Okay, so this shows first part. Show that f has a root of multiplicity 2 at x equal to 0. So try to find derivative of f. If mth derivative is non-zero and before mth all derivative are 0, then multiplicity is m. And here m is 2, second derivative is non-zero, first derivative is 0. Now second case, we apply Newton's method to find this root. We apply Newton's method, or you can say we apply modified Newton's method. Starting with, you can take initial guess. रूट तो 0 ही है ना, दे ही रखा है, 0 के पास जाना है. So you apply Newton's method starting with any initial guess near 0. So I am starting with 1. Then iterations are xn plus 1 equals to xn minus multiplicity m, then fxn.
Excuse me.
हाँ जी.
So if we put x is equal to 0 in f of x, then we will get 0. So taking x not equal to 1, वो एक root नहीं मिस हो जाएगा.
1 पे क्या?
x is equal to 0 पर
हाँ.
we get 0. f of x is equal to 0.
हाँ वो तो रूट है ना, तो एफ एक्स तो जीरो है ही, एफ जीरो इज जीरो।
तो एक्स नॉट इक्वल टू वन लेने से एक और हमारा रूट मिस नहीं हो जाएगा?
नहीं, हमने जीरो वाला रूट निकालना है। ओके, सो यू कैन स्टार्ट, you can take any initial guess near zero. You can take 0.1, you can take 0.5, you can take anything.
सर आई एम सेइंग इफ एफ ऑफ जीरो इज जीरो दैट इज
हाँ
समथिंग वी न्यू, एंड देखने से पता लग रहा है कि इफ वी पुट एक्स इज इक्वल टू जीरो
हाँ,
फंक्शन के अंदर, तब हमारे पास एफ ऑफ एक्स इज इक्वल टू जीरो आ रहा है।
वो तो थ्योरेटिकल हो गया ना, कि वेरीफाई कर रहे हो कि जीरो रूट है। अब आपने न्यूटन्स लगाना है। अगर
तो सर
जीरो,
अगर एक्स नॉट इक्वल टू वन ले लेंगे तो फिर वो जीरो तो मिस हो जाएगा ना?
जीरो कैसे मिस हो जाएगा, वो इनिशियल गैस है वो तो। इनिशियल गैस तो आप रूट के पास में कोई भी पॉइंट लेते हो आप। ये
तो
तो,
बट नेगेटिव साइड नहीं लेते उसको, मतलब रूट से कम?
ऐसा तो कुछ नहीं है, मल्टीप्लिसिटी फिर रिलेशन थोड़ी है रूट के आसपास में। आप बाइसेक्शन में आप जो करते थे, आप आपका ये रूट है, ये एक्चुअली जीरो रूट है इसका, इक्वेशन का ये रूट है। तो जीरो के लेफ्ट राइट में आप कोई भी पॉइंट, यू कैन टेक एनी इनिशियल गेस नियर नियर दैट पॉइंट।
ओके।
ओके, इनिशियल गेस इज नॉट रिलेटेड विद मल्टीप्लिसिटी। और
ओके।
साइन साइन चेंज देख लो इसका। जीरो के लेफ्ट में एक वैल्यू ले लो, एक राइट में ले लो, उसमें साइन चेंज करेगा तो जीरो रूट है। अब जीरो तो, क्योंकि हमने इसने तो कह दिया कि जीरो रूट वेरीफाई करना है एक्चुअली, तो जीरो से शुरू हम नहीं कर सकते ना, कुछ और से कर लेते हैं। जीरो तो रूट है ही। So I am taking just an example. Initial guess, you can take anything. You can take 0.1, you can take minus zero point 0.5, you can take minus 1, you can take anything. Okay, मेरे पास ये सॉल्व था, मैंने लिख लिया, बाकी आप कोई भी ले सकते हो नियर जीरो। So this is fxn, this is f dash, derivative is e power xn minus 1. So start with 1. So first answer 1 minus 2 e power 1 minus 1, then e power 1. So simplify it with calculator. This is 0.16395. अब इस आंसर को फिट कर दो यहाँ पे, 0.163 e की पावर 1.0.163, ठीक है। Then x2 is next answer is, you can check this method quite fast. So डबल जीरो आ जाएगा, और थर्ड इटरेशन में दिस इज 0.5 zeros, 1 2 3 4 5, and so if you do 4 5 times, you will get almost zero. So I'll stop here. So you can put a stopping criteria as per the requirement. Okay, and so on, etc. Let us take one more example of second case. The equation x cube minus 7x plus 16x minus 12 has a root of multiplicity 2, uh, has a, you, you can modify it, has a multiple root at x equals to 2, starting with 1, find root, correct to 3 decimals, using modified Newtons. So this problem says that you have a multiple root at 2, but multiplicity is not given. Can you find multiplicity? Find कर सकते हो multiplicity? नहीं, कैसे फाइंड करोगे? fx is this, write its first derivative, okay, plus 16, and then write fit x equals to 2. क्या आंसर आएगा? 2 4 12, it will be 0. So find its second derivative, then fit x equals to 2. So what you get? Second derivative is non-zero. So multiplicity is 2. So root is given. So you can apply both method. Either you apply previous one or you can apply second one. So I am applying second one. We apply modified Newton's method. Newton's method. So I am using this formula xn plus 1 equal to xn minus f dash, then f dash xn square minus f double dash. Okay, so use this formula, fit values here. Let us start with root is 2, so you can start with any point. It is given here 1, so 1 given here. Okay, so start with 1. Start with x0 equal to 1. You have इसमें फिट कर देना. नेक्स्ट इटरेशन जो आंसर है x1 is that is 2.111 and x2 is 2.0078 and x3 is 2.503. So this is almost 2, so we stop. And you can say root correct to 3 decimals is 2.00. And you can also apply another formula, but if you don't use m like here, if you don't use m here, still you will get answer, but you may have to perform more iterations. जैसे यहाँ पे तो 3 पे बन रहा है ना, x3 is almost 0, but then maybe you have to perform 7-8 iteration. So iterations can be doubled if you don't use modified Newton's method. Any query? Anything you want to ask?
No, sir.
Okay, so this is the end of this topic. That's it in root finding problem. So we have studied four method starting with bisection. So let us make a conclusion. So firstly, I started with simple roots, and in this scene we have studied bisection. Then we have studied fixed point, and then secant, and then Newton. And then I moved to multiple roots, and as you know that बाइसेक्शन में तो जैसे आप मल्टीपल रूट निकाल रहे हो, अगर इक्वेशन पॉजिटिव ही है या नेगेटिव है तो यू कैन नॉट अप्लाई बाइसेक्शन. और फिक्स पॉइंट और न्यूटन तो सिमिलर ही है ये ऑलमोस्ट, एंड वी डोंट गिव मच weightage to secant. In secant, that ratio can be problematic sometime. Okay, so fixed point and Newton, they are similar. So for multiple root, I have written, so you can apply this formula for multiple root as well. Simple Newton वाला भी लगा सकते हो. You can apply, but then you get linear convergence, first order. And then we have two modified Newtons. One is this with M. Okay, so that give you quadratic or second order convergence. And another one is this x1 equals to xn minus f dash upon f dash xn square minus f double dash. So you can use these two formula with second order convergence for multiple roots, and if you know m, then try to use this formula. This has less computation. This and the topic roots of nonlinear equation in one variable. Anything you want to ask? Okay, so I'll stop now. In next class, we will start new topic, system of linear equations. In this
Thank you, sir.
in this chapter, we have studied one equation, and in next chapter you may have two equation, two unknown, three equation, three unknown. Okay. Try to solve the problem. The website link I have given you. There are chapter-wise exercises with solutions. So please give a try to solve, look at those problems. In numerical analysis or in mathematics, if you won't solve any problem, then you won't learn. So try to solve two, three problem of bisection, two, three problem of fixed point, and maybe one problem of secant, two, three, four problem of Newton's method. Try to solve those problems. Okay.
So if you could just share that link once again.
अभी तक LMS पे भी मैंने डाला, मेरे नाम के नीचे देखना, परमजीत सिंह.
सर पहले वाले पेजेस पे जा सकते हैं एक बार, प्रीवियस पेजेस पे,
और
ऑन द
just type num as in Google. Previous.
सेकंड। तो इसमें मल्टीप्लिसिटी हमने 2 फाइंड आउट कर ली थी, फिर भी आपने सेकंड मेथड यूज किया विदाउट मल्टीप्लिसिटी वाला।
Okay, so then see you next in next class.
ओके।